Alright, what's up everybody? Welcome back. Learning to program in C is what we're doing. We haven't done much programming. I feel like I might have been getting a little in the weeds in terms of like theory and stuff. So today we're going to actually write a program of arguably some utility, right? Maybe not, obviously the most difficult or challenging thing, but something good uh, in terms of like sort of a first program. Uh, so I'm going to create a new thing. I'm going to call this far converter.c for reasons that will become very obvious in a second. But before I get started, I am going to real quick do color scheme change. That's a colon color scheme if you want to the reason, like, usually I just leave it as default, but when I was looking back at the last video, the dark blue comments uh, didn't really look good. Like, they look fine on my computer, but for some reason when they go into the YouTubes, they don't look real great. So I'm going to change the color scheme so that maybe the stuff's a little bit easier to read. You can do that by typing colon color scheme, as I have done down at the bottom there. And if you hit tab, you can kind of go through and see all the different kinds. I'm going to pick Elf Lord because I am a Lord of Elves, and I just kind of like the name. And the other thing that I'm going to do is I'm going to change my tab space. When you hit tab, generally it's a good practice to hit tab and do sort of indents when you're making code blocks. And I haven't really gone into that. Maybe I will a little bit more in this video. But VI's default tab is like 8 spaces in, which is really a lot, and it doesn't look very good. So if you set TS equal to 4, then it'll only be it'll only be 4 spaces in instead of 8. So now when I tab, it's not like this was 1 tab before, now that's 2 tabs. So that's better in my opinion. Anyway, enough of that. See my new comments color scheme here. That's real good. This is going to be a Fahrenheit to Celsius temperature converter is what we're going to be making today. And I'm real quick going to sort of write some specifications, which is otherwise known as specs, generally called specs, which is short for specifications. I'm not going to go super into detail because it's going to be a pretty simplistic program, but it's good to always kind of keep in mind what you're actually trying to do, because otherwise you might write some really neat code that turns out to not solve the problem you were trying to solve. So it's always good to make sure before you start coding that you know what it is that you're trying to accomplish. So what it is that I'm trying to accomplish is I'm going to try and print out a list of Fahrenheit temperatures and their Celsius equivalents. So we're going to, starting with 0 degrees and 20, 40, all the way up to 300. So I have the output of what I want it to look like over here. So see, these are all my Fahrenheits, right? 0, 20, 40, 60, 80, 100, all the way up to 300. And then these are those Fahrenheits converted into Celsius, right? Because Celsius is a different way of looking at, a different way of representing temperatures. So 0 degrees Fahrenheit is equal to roughly negative 17 degrees Celsius. And that makes some sense because we know that 32 degrees Fahrenheit is freezing and 0 degrees Celsius is freezing. So we can look at this 40 and this 4, and they're kind of close. So we can sort of verify that that is correct, and that is in fact correct, that output there. So that's what we want our output to look like. And we're going to use sort of this standard conversion formula that I'm going to also put up here. We know that Celsius is equal to 5/9 times Fahrenheit. I'm just going to put far because that's a long word to write. Far minus 32. So whatever your degrees are in Fahrenheit, subtract 32 and then multiply it by 5/9, and that will be your Celsius. So that's what we're going to do today. And before we go any further, I'm going to go ahead and include, there you go, be blue, standard.io.h, because we're going to we know we want to print it out, right? So we know we're going to need that printf function that we discussed earlier. And then we know we're going to have to write our main, because that's going to be sort of where our programming takes place. And now this particular program is going to require us to make use of some variables, right? So the first thing we want to do is declare our variables. So this is, I'm going to call this int far for Fahrenheit, and I'm also going to make a Celsius one. And I didn't cover this in the last video, but if you want to declare two variables of the same type, and you're just declaring them, you're not assigning them any values, you can declare them both on one line if you put this comma in between them. So I have a far and I have a Celsius, and they're both of type int, and neither of them has really been assigned any variables. They've just been declared. And then I'm also going to use some helper functions, or helper variables I should say, and they're also going to be ints, and I will explain what these are used for in a moment here. But it's always important to put a semicolon, but also it's good practice, I should say, to declare all your variables at the very top, right? And there's two reasons for this. The main one really is just that it's easier to figure out what's going on if I have all my variables up at the top, right? Because maybe I don't need this step variable until like way down later in my program. But if I declare it down there, then it's like I have to go looking for all the various variables that I have. So it's better to declare them all up here, and then we'll use them when we need them, but let's declare them first. So I've declared all my variables that I'm going to use, and then I'm going to assign some values to some of these. So I'm going to call my lower 0, and the reason I'm going to do that is because if you remember from up here and also my desired output, right, I want to start at 0, right? So 0 is sort of my lower bound of my Fahrenheits. So I'm going to go ahead and declare lower to be 0, because that is the lower bound of the table, I should say. It's a table, right? It's a table. And then upper, you may have guessed, is going to be 300, because I'm going to tab this over so they're all in the same line, because I'm anal retentive like that. The upper bound of the table, and then step. And you might be wondering what step is going to be. It's going to be 20, and that should make sense maybe because this is the interval of the table, right? Because we're going to do 0, and then we're going to do 20, and then we're going to do 40. So we want to kind of go up by 20 each time. So it's good to have that sort of in a variable so that we don't have to just magic number hard code the value 20 in there. So the first thing that I'm going to do is I'm going to assign far the same value as lower. Now we didn't cover this necessarily, although I also spelled it wrong, so that would cause problems if I didn't catch that. But you can assign a variable the same value as another variable, right? So this lower currently, if you remember the boxes I drew in the last video, this lower currently has a value of 0. So when I say far equals 0, well, I say far equals lower, but the computer evaluates this, everything on the right of the equal sign first. So it looks at this lower and says, what is lower? And it looks and it says lower is equal to 0. So we're assigning 0 to far. Now far and lower are not the same thing. They both have an equal value. We're actually copying the value of lower and putting it into far. So I can then change the value of far and it won't change the value of lower. And that's important to remember for later when we get into pointers and things, because it can get a little crazy. But for now, these are two separate things that just happen to equal the same thing right now because we've copied the value of lower into far. And now, obviously, we've got to do our calculation based on this sort of thing up here, right? So we can say Celsius is equal to 5 divided by 9 times far, which is our variable, minus 32. Now, I didn't go over mathematical operators in the last video, but most of them are pretty self-explanatory, right? C, and in fact, I think all programming languages follow PEMDAS, which is parentheses, exponents, multiplication, division, addition, subtraction, right? In this order, right? So it's going to evaluate, it's going to do these things first and these things first, and there's no exponents in this one. So then it's going to do multiplication, so it's going to multiply these two things together. And it would do this last, except I put it in parentheses, so they're already done, right? And the minus symbol, this is a minus symbol, right? The minus and plus work as you might expect. Far minus 32 is going to be, in this case, 0 minus 32 is negative 32. This star is multiplication. Sometimes it's written as an X in like on paper, but in C and pretty much every programming language, and even Microsoft Excel and stuff, like the star is multiplication. So hopefully that's not groundbreaking to anybody. And the division sign is 5 divided by 9 is the symbol here. The only thing that might be a little bit surprising to you is because 5 and 9 are both integers, this value is not going to be, this 5 divided by 9 is not going to be exactly what we expect. Because 5 divided by 9 is a little over half, right? It's like 0.59 or something. I don't know. I'm not going to actually pull up my calculator and do it, but we know that it's less than 1, right? Because there's less than 1 9 in 5. So, but remember when I talked about integers the other day, I was saying that integers don't have a notion of decimals. So what's going to happen here, because 5 and 9 are both integers, is it's going to truncate away the decimals, and otherwise it's just going to sort of round it to whatever whole number it is. Unfortunately, in this case, right, 5 divided by 9 is going to be 0 point something. So if we get rid of those decimals, we're left with 0, right? So if this evaluates to 0, this 5 divided by 9, then it doesn't matter what this becomes, because anything multiplied by 0 is going to be 0. So we're going to get 0 for all our Celsiuses. So that's not going to work, right? Luckily, we know a little bit of algebra, so we can sort of change our order of operations around a little bit. And we're just going to say that 5 times Fahrenheit minus 32 divided by 9, right? Because this is the equivalent statement, right? We know that 5 over 9 times Fahrenheit minus 32 implicitly over 1 is the same as combining them into 5 times far minus 32 divided by 9. Now, obviously this is still going to truncate it, and in fact I will pull up my calculator real quick here. Calculator, because if we do that math, 5 times well, I'm just going to say negative 32 because we know 0 minus 32 is negative 32. And then we divide that by 9. We end up with negative 17.777778, which if you remember from our specs here, we only got negative 17. So it is going to truncate off this end here. But it's going to be close enough for our purposes that we're just going to sort of have them all be whole numbers for now. So that's how we're going to do the calculation. The next step, obviously, now that we have far equal to 0 and we have Celsius equal to negative 17, we're going to want to print them out, right? That's what we're trying to accomplish. We're trying to print them out. And you might be tempted to just say print out far and space and then Celsius, right? Unfortunately, this isn't going to work because these are not strings. These are variables. And if you remember from the last video, we printed, when we used printf, we used a very special type, a const char array, sometimes referred to as a string, needs a string, right? So we need to have a string. We can't have just these int variables. And we could put this, and this won't break. The other way it would actually break, but this way it won't break. Oops. If you want to delete a line, you press D twice while you're in the command mode there. But if we print this, then all it's going to do is it's going to print the word far space Celsius, right? So that's also not going to work. So there is a way. We need to convert these to strings, essentially, is what needs to be done. And we could do that ourselves, but that's a lot of work. So we're probably not going to do that ourselves. In fact, not in this video. But what we are going to do is we're going to take advantage of sort of the special way that printf allows us to do what we need to do, because it's a fairly common thing to want to print out variables. So luckily there's a built-in way in printf of how to do it, and that is to use the percent sign. And the percent sign is kind of like, if you remember that new line character, that /n that we had, right? That told it, don't actually print /n, print a new line, right? So the percent sign followed by some letter, in this case a D, right? Says don't actually print %d, print the next argument in the list of things that I have given you, right? And it depends on what type they are, but because we're using ints, we're using %d, which I don't know why they didn't make it %i for int, so they would keep it consistent. But I think %d is for digit, but I don't know. I feel like they should have had it be %i, but they didn't. It's %d. It's whatever. Obviously they know more than me, so I'm just going to leave it alone. But what it does is it says, okay, I'm printf, I found a %d in this string. So I'm going to go to the next thing, the next argument, and I'm going to convert that into a string, and I'm going to put it in place of this. So it's going to grab far, it's going to convert that 0 into a string of still the character 0, and then put it in there, and then it'll be able to print it, and that'll work. So then if we put a space and another %d, right? Now we've got another %d. So then it says, okay, I got another %d, so I'm going to go to the next thing in the list, which this time is Celsius, which happens to equal negative 17. So in this case, it's going to convert that negative 17 into the string -17 and put it right in there. And then it'll print this new line because I put it there. And that will be what we want for that first line. So I'm going to go ahead and save and quit. I'm going to compile our far converter.c, and then I'm going to run it, and we got 0, -17, just like this one. But obviously that's not going to be quite enough for what we want to do. We want to print out all the rest of these as well. So this video is lengthy, so I'm going to go ahead and stop it here and do a part 2 where we print out the rest of these. And you might say, took a long time just to print this first line, like how long is it going to take to print the rest of these? Well, we have the basic building blocks now, right? Like we have everything written. Oh, Elf Lord. We just want to do this sort of over and over again. And that's kind of a hefty topic on how to do this over and over again. So I'm going to do that in the next video. I will see you then. All right. Bye.